Hello everyone and welcome aboard. We're Idan and Tomer from the College of Management Academic Studies, and we'd like to introduce to you a project we've designed and implemented during our summer course at the College of Management, targeting Java techniques and algorithms. So let's get started with a brief introduction of the algorithms that form the basis of our project. We have the BFS, that is algorithm that gets you from point A to point B in the fastest way, shortest in our case, but may consume much more resources such as memory and stack management depending on your implementation, due to its nature to develop much more possible paces until it reaches its final destination. We have the DFS that, however, may usually take shorter time to calculate, though it is a stiff algorithm, sticks to a given path until it reaches a deadlock and then trace back and tries with another direction, may not give you the fastest and shortest path. You may pause to take a deeper look into the pseudocode provided for the BFS algorithm. So let's deep dive into our project. We're speaking about 3D Maze. So we have the client, which you can see here, that can choose the GUI or CMD mode view. And we have the server that is here to help them solve their way to their final destination. The server can be configured by an XML properties that can give him the properties like his IP, his port, the interface mode, is third pool and searcher algorithm. Let's start the server and see how the client connects to it. So the server started, and we'll choose the GUI interface for both clients. You can see that our team is the cookie monster, and our job is to get him to his soulless cookie. So we have many options to load a maze. We have a database that is compressed, and we can load a maze like Tom here, another maze in client B. As you can see, we can move the character through the maze, but we can save us the ache of solving the maze by connecting to the server and asking for the solution. Here it goes. So the solution, the server now serves the client, and as you can see, it reports us that the connection is alive, and you can see the character moves and reaches its goal. What you can see in our maze is that we can even zoom in and zoom out. But before we do it, let's take another maze. We can load a compressed maze, and then you can see we have our character, and we can zoom in and zoom out. So we have loading of compressed files. We have our database. We can generate ourselves a maze. And of course, we can use the help of our server to serve us to the destination. So this is for now. Let's go back to the architecture. So the maze is built on the MVP concept. The MVP concept enables implementing a more decoupled and much more coherent and generic systems. There are three main elements: the view, the presenter, and the model. The presenter serves as the facade to both the view and the model, presenting a minimal and coherent interface that both parties may request services from each other. With this interface, the view is responsible for user interaction and receiving comments that will ultimately be executed by the logic implemented in the model element. The model notifies its observers, the presenter, of finished jobs and tasks that are ready to be dispatched to the view model. This creates a clear segregation between the element's responsibilities, saving the concerns of the GUI to the view implementers. We'll dive into our code to see how we implemented this model. So you can see that in the presenter, we have the facade. This is the comments, the API, simple API that both the view and the model can interact with each other. On the system initialization, we register the presenter to be both the observer of the view and the model. And when the model gets a task from the view, such as let's solve the maze. So you see that it creates a connection to the server, but what's important here is that after he solves the maze, excuse me please, after he solves the maze, he notifies the observer of the new state, solution ready. This will be delegated for the view to present their solution. Let's see that we have a solution ready and the view is responsible to display the solution. We'll just move to, so this is our client side. We have also the server side, which we want to focus on the implementation of the BFS. So, in order for the maze to be solved, we need to adapt it to be a searchable object. Searchable object has characteristics such as what is the cost for move from point A to B, and if I'm in a certain point in the board, what are the possible moves that I can make. So this adapter, the Maze3d adapter, enables the BFS algorithm to get this information about the maze and then solves the maze properly. So this is the implementation. You can see that is very neat and clear implementation of the BFS. As explained before, the BFS can give you the shortest path to the final destination. It's very straightforward. So that's it for our project. Thank you again for watching. Thank you very much for our lecturer Nisim Barami for a wonderful experience. We've learned a lot and we're grateful for this to happen. Thank you very much.